So next session is
Session has started, no?
so next session is on SDN. SDN is basically software defined network, right? Software defined network is a kind of a network where we have a different, let's say what we are doing in our networking, right? When any data
Excuse me,
has,
sir. Sir,
yes,
sir, please share your screen, sir.
it is already shared.
मैम शेयर कीजिए सर.
Shireen ma'am, you stop presenting.
हाँ मैम.
Now it is visible.
Yes, sir, it is visible.
Can you hold a second? Wait a second, sir. Okay. Okay, let's start. So, so next session is on SDNs. SDN is basically a software defined network or software defined networking, right? So what happened when we are defining a network, when we are defining a data exchanging mode, right? So as if you have any idea about networking, so in networking, what happens when any data comes from any, computer, right? And it is going to the different protocols, different layers. There is a different layers which has been made. I'm first of all, I'll give you some, a brief about the application, the layers which has been used with the networking, right? So first of all, I'm giving you something. If anybody has no idea about networking, it will be cleared with this. Okay. Networking. Okay. Network layers. Right. Let's take an example. This is called OSI model, right? So in a OSI model, basically, which is used to take, these are the combination of layers in which the data from one machine to the application is being sent with these layers. The first of the layers, which is called physical layers, second is data link layer, third is network layer, right? Physical layers means your fiber, wireless, hubs, repeaters, right? So that is basically the physical layers. Data link layer to organize bit into frames to provide hop to hop delivery, right? So it is a data link layer, and this is all the hardware or lower layers, means where from where data is generating, right? So that is the layers of uh, hardware where it is being generating and is set to send to the another layers as a transport layer, which is used to transport from one machines or a lower level to the higher levels, the upper layers, These are the upper layers, which is session layer, presentation layer, application layer. These are the upper layers, or you can say software layers, right? So when you go for the physical layers, we have different hardwares like fibers, wirelesses, hubs, and repeaters are there, right? And then data link layer, which is used to organize all the bits into the frame. And third is network layer to move packets from source to destination to provide internet working, right? So these are the layers. This is hardware layers itself, and then it will be going to the transport layer to provide reliable processes to process message delivery and error delivery. If you can send your data or not, it will be compiled into the transport layer, right? So it can be moved forward or not. So that is the transport layer, which is out of OSI, means a kind of transportations of data from one end to another end, right? And then in the software ends, there is a session, presentation, or applications. Session is to establish, manage, and terminate sessions, right? If you are using, what is session? Basically, this is a kind of information that you give to the you know servers, right? This is a server based layers, right? Means if you are sending any information, if you are requesting some informations from the servers, so what happens? So what, how many times it will be existing for you, right? It doesn't mean that you are requesting something, it is always for you. No, it is not always for you. It is available for you sometime, right? And this is called session. This is called session. Session is an information which has been saved with that server for that particular time, right? Like I have used my Gmail, right? For I have logged in my Gmail, and if the Gmail is there, and I have read my all messages, and after that I forgot to log out. So if I forgot to log out, so for how much time, or when I'll be, again using it, I don't know, right? But next time when I'll be using, so login will be there or not? No, there'll be no login, right? Because that information is not saved for a longer time. It is saved for a particular time, for a time limit. If I use it again in 1 hour, within 1 hour, so I'll get that information again, and I don't have to, again log in. But uh, when I want to log in, when I want to use again after 5 hours or 10 hours, then it will be automatically logged out. Why it is logged out? Because of that session timing, right? So session is some kind of information that is saved from a client to a server for your benefits, basically, right? You don't have to, use, like, say, or one more information, one more application is there. Like, I have opened Flipkart, and I have opened Flipkart with my login or not login. It doesn't matter. But I have put some products into the cart, right? I have added some products into the cart. So I have added 3 to 4 products. So what will happen? It will go to the cart, and it will existing in your cart since you have started to the 1 or 2 days, right? Or 3 days. Either you have logged in or not, it doesn't matter, right? You have not logged in, you are again, if you are using only Flipkart and you have not logged in, you are actually logged it with the guest user. And whatever the operations you have done with that Flipkart, it will be saved into the sessions, right? And that session is managed by session layer, right? Which stores your application for a while, right? And the while could be 1 day, while could be 2 days or 3 days or 4 days. It depends what the timing is set to that session, right? Like if you go for the net banking, if you want to access your banking with your internet, and you have done your transaction and you forgot to log out, what will happen? Will it be logged out automatically? Of course it will be, because the session is very shorter. The information is already there, but you have not logged out, so information is not gone there. but the session is been terminated because of timing, right? Because the banking session are very less, very small for the small time, and normally we have a larger timing, right? For using any application. So application is based on the sessions when you'll use it and how much time you will go for it, right? For that application, and for that timing you'll get the same information around when you use it. So the session layer is basically manage the users, right? It's basically manage the users. Then is presentation layer. Presentation layer is to translate, encrypt, and compress the data, right? So whatever the data or the information which is coming from the hardware is going to the session and the presentation layer to present it, how it will be presented into the servers, and the application layer is to allow access to the network resources. This is the basically scenario of any networking when we use data, transferring from one network to the another network, right? But the thing is, when data is into the transport layer, right? This comes into the transport layer. So when it is in the transport layer, what they do actually, how this happens from year to year, how it is going from hardware to here. So because of the edge devices means routers and switches and hubs. These are the edge devices. Because of this transport layer works, right? So devices layer, transport layer takes all the data from one end to the another end. So it is a transporting the data, and it is used for the messages delivery and taking the data from the hardwares, right? So when we come to the so what happens basically when we have multiple, uh, let's say routers, right? So when any request has been sent to any routers to transport their data to the another, layers. So what happens? I'm not able to find the right image. Okay. It'll be done. Right. So data plane, here we use a data plane. What is data plane? Data plane in SDN, in a networking of SDN, we have a data plane, we have a control plane, and we have an application layer. Right. And what is data plane? Data plane is nothing where data is generated and encrypted. This is called data plane. Right. Like you have three layers in the hardware systems. Like you have a physical layer, you have a data link layer, right? You have a network layer. So that layers is basically called the forwarding layer or data plane, right? Where data is generating. Yeah. Next is it goes to the routers. Let's say it goes to the routers. Now routers, what routers do actually? Routers basically take the information about the location where it is to be sent, right? Where you want to send it, in which server location you want to send this request. So router again have an intelligence to check that what kind of location you have given, that where this request has to be linked, right? That has a intelligence of router. Router actually checks about the several locations from there, and it will check the congestions also. Router also have a ability to check the congestion of networks, right? If the congestion of networks is very less in one network to another network, so it will choose the network where the congestion is very less, right? So it has two intelligence that first it will check the location where your data request has to be landed first. So it will send that kind of routers, and second, and that transportation will go by that kind of transport layer, and which transport layer is very less congested, and the congestion is very less. The traffic is very less, so that your data will be sent to the destination point at a very minimum time. So that is basically generated with that routers, right? But the routers, if there are multiple routers in the transport layers, right? One router will connect to the another router will transport that data into the next routers, right? So in between there are multiple routers which are transferring your data from one routers to the another routers, another to next another, and finally it will go to the destination point. And each and every routers has an intelligence that they can decide which network path they will choose to forward your data from one to another. Yeah. So basically, this is the intelligence of routers. Routers is that much intelligent. That kind of algorithm has been set to that routers, right? But the problem is each and every router has their own intelligence, right? And every router can think about the data when and in which path they will follow to send your request from one end to the another destination end. Every router can think, right? And they can take their own decisions for the locations and for the path, less congested path they will decide. So their decision is their own. But here is a problem that each router needs to be configured. Each routers needs to be configured that each routers has, you have to put intelligence to each of the routers, that you will find this path and path. How do you think? So you'll think by this, software. So they have their own softwares, they have own their mind, and that mind comes from any softwares. So each and every routers has some kind of intelligence power, that kind of decision making power, so that they can land your request to the servers, and they can, again taking back the response from the servers uh, to the users, not by the same way. The way could be different because the congestion could be different, right? It doesn't mean I have go to the, I have started here and I have traveled to the point of B. Started from A, I have to go to the B point. So I have chosen a path. There are two or three paths, or more than two or three paths are there. So I know how do we go there, but first I need to intelligently choose that which path I'll select so that I'll get there to that point at a minimal time, right? So if that I just choose it by one thing, right? First I'll go, or I'll take the data packets from each and every network, and to the in each and every path. And if any of the data packets is very congestive in any path, so I'll not go there. So I can choose from there. But the problem is every router will do the same thing, right? So sometimes it will think intelligently, sometimes it will not able to do that very intelligently, right? Still we are doing the same thing, but the technological enhancement will make the different or enhanced thing, like an SDN. SDN is a technological and advancement of these data transportation. SDN can make a software defined controllable network. software defined control. There are two things actually happens with this routers. There'll be a data plane and there is a control plane. Data plane is taking the data, encrypting the data. Whatever the processes the data is has to be happens with the data is with the data plane. And the decision making system is done with the control planes. Fine. And the control plane, each and every routers has their own control plane and data planes. Each and every routers have their own data planes and their control planes. Data planes, which is coming from your devices, which is data planes, and the control planes where it is taking the decisions, what kind of locations they find by that request. Because if you are writing any request, you have some server locations, right? You have some path into it, and they can find that path, they can find that locations by your URLs and all, and it will land, it will take your data from that devices to the that server location, right? And it will also check, and the control plane also check whether which is the less congestion path, so that it will travel that with that data in a very less time. That happens actually. But here, if we are applying multiple routers, we need to configure all the routers multiple times. If we need some changes, so again, we'll have to apply multiple times changes with the different routers, which is applied with that. Right. So that is a problem. So what happens with the SDN? It takes the control plane from each and every routers. Means it is taking the decision ability from each and every routers, right? And we are making a software integration that has the ability to control the all routers within the network. A single network unit which can take decisions. So now what happens, the decision making abilities of each and every routers has been taken from there, right? They don't have their decision making which paths will choose or not, right? So they have only one thing now, they have only data planes. Routers now have, in SDN cases, routers have only data planes, no control planes are there. SDN make all the decision by itself by integrating in between them, right? All the routers which were circulated to each other, what SDN will do, SDN takes all the controlling with itself, and whatever which path needs to choose is been given by SDN only. It is not given by now router. Router will take as a switches only. It will forward your data from one side to another side. Only data, not decisions. It doesn't have any decision capabilities. Now the decision capabilities has been finished from that router. Now in SDN cases, the SDN is the basically controller, right, which has the decision capabilities, and all the routers which are in the network has the what is the data packets they are traveling with, and what are the kind of congestions are there, that is already logged with that SDN. So SDN have all the information about the network, all the information about the network. So it can manage things very well, because all the routers, all the network congestions and the transporting layers situations, all is been done with the, all is been surveillanced by the SDN. So SDN is nothing, it's a centralized unit made with the softwares, right, for decision making for the routers. It is used with the networks, right? So that is a kind of that is kind of a software enabled or software defined networking, and this is SDN controller, right? So in the SDN controller, we have the data planes, but the data planes coming from the network devices, right? Any network devices like switches and routers, right, and hubs, and that data planes will contact to the control plane directly, and control plane will be single, right? So all the decision of those data planes forwarding system is come from the control plane. And control plane is software based. It has all the thing, means it has all the logging systems of application networking and low layers networking, right? So it is basically a kind of a controlling system which can control intelligently all the things. Means all the intelligency from different routers is been taken out from there and given to the control plane of the SDN controller, right? So now it has all the surveillance system of all the networks, right? And easily it can take a decision that which data has to be go with which path, right? That is what do with the SDN. So this is the application layer, the business application layer where all the data has to be landed, right? So now, if we come here, so software-defined network is a networking technique that communicates with the underlying hardware infrastructures and direct traffic on a network using software-based controller or application programming interface. Right? It's a software. Of course, it is software. So it is a software, and it is directing basically your data packets to which path you'll have to go and which application you'll have to. Traditional networks, on the other hand, requires specialized hardware device such as routers and switches to govern network traffic. SDN can use software to establish and control a virtual network as well as the traditional hardware. While network virtualization allows organization to segment different virtual networks within a single physical network, right? And or connect devices from the different physical networks to form a single virtual network, right? So here is the thing that we need to make a single virtual network with the help of SDN, right? Provides a new way of control the data packets routing through a centralized layers. So here we have a controller. Here we have a, and there is basically two kind of APIs working. API is nothing, it's a programming only, right? So from lower end application to higher end application, right? Lower end application means user based application. We are on the lower base application and we want to request a data to the higher end application. It means server, right? So this is the server application. Here in the infrastructure layer, we have the access points, your routers and sensors, nodes and all. So this is called southbound API. When your router and switches has a connection with your data, it is called southbound APIs. Yeah. So southbound API is nothing. It's a kind of algorithm, or it's a kind of APIs. It's a kind of processes which handles the lower layer systems, right? And then it is go to the controller, and controller is connected with the application, which is called northbound APIs, right? So there are two type of APIs is basically here. One is southbound APIs and one is northbound APIs, and this is the control layers where we have data server topologies manager and device manager controllers. So here we are managing our data, right, packets and transferring from here to the application layer. So it's a centralizing. Basically, we are doing nothing. We are centralizing. The mind of routers is being taken out and centralized with the software, right? Because that intelligence is also made with some softwares. Nothing else. Obviously, the commands and whatever it is written is a software, right? Each and every routers has a software. Each and every routers has a software, and if it is a software, all this that software is very vast. The SDN software is very vast, and it has lots of intelligence. It has a large tracking systems, right? So advancement of networking is there, right? But obviously it is not a thing that is a different concept. No, it is not a different concept. It is the same thing, but the thing we are managing all of the things not with the hardware, with the softwares, The software can decide it very well, and we need not to configure each and every routers and not each and every lower systems in edge systems, right? So in a single unit, whenever we want to configure anything, we want to changes anything, we just have to use the SDN only. We don't go with the routers and all, right? Let's say you have an internet problem in your area, right? What will happen? So there are first thing they'll check with your connections, right? With your with your CPUs and all, right? Your uh, data cable or the cable you are using, the internet cable is properly inserted or not. First it will check, and it will go to the router configuration is right or not. Then it will go to the main router, then they'll check whether this router configuration right or wrong. So it will check for the the wires connections and all, and then it'll check with their own system whether it is working or not. Kind of each and every system is need to be checked when we need to find out any problems with this networking, right? But it can be resolved by this only, because there is nothing. You'll have to only connect your system. There is no intelligence, no configuration into it. The router doesn't have any configuration. They don't understand the thing, what kind of path they will choose or what kind of decision they can make. They doesn't have anything. The all controlling thing is coming from any SDN. So that's why in a networking we use SDN for that purposes, right? The logging system will be there, surveillance system will be there, and the intelligence will be faster, right? The decision making will be faster, and we can apply, and they can be easily and efficiently working, right? Because SDN has all the ideas about network, right? All the ideas, the total networks has been controlling from us one single unit, one single software. So if it is working or controlling from one software, means it is easily to handle all these things from a single way, right? Like you have any application, that application have everything. You can shop it, you can you can consult a doctor. So you generally you pick any application, that application has all the things into it. You don't have to go from one side, one application to the another application to the another application, right? So nowadays, if you go for the application, what you see that each and every applications has uh, lots of things into it. If you go for the Flipkart, they have groceries, they have clothes, they have electronics items, they have medicines. You can purchase like you are purchasing into the in a multi-brand showroom. Means you have everything into it, right? So if you have everything into it, means you don't have to install the different applications for purchasing. The same application is working here, right? So here in SDN, you have a single unit which are controlling all these things. So why we need different configurations? That is not needed actually. Right? So SDN do the same thing. And feature and benefits of SDN is it's a simple operation. Reduce complexity by decoupling and control and data planes, while making automation highly secure and scalable. If there is a security, in terms of security, you can use software very secure, right? And security could be very high because you can make any software very secure. There are lots of things you can apply for the security. Multi-layered security, you can say that there will be multi-layer security in the software. Hardware it is difficult, but in softwares we can have multiple securities and a single application you are doing it. So there is no expense will be generated when you apply in a single unit, right? In routers, if you are applying multiple routers and you need to configure security in the different routers with the multiple layer securities, you need to configure it all the routers with it. That is more difficult, right? Second, it is scalable also. You can scale it in a large scale, and if you have a very small scale kind of SDN you want, so you can have a small scale and a large scale. Means it is very scalable thing, right? achieve faster time to market, deploy application and services faster by leveraging open APIs, easy integrate third-party products, build programmable networks, right? Eliminate manual configuration, provision and manage data centers, campuses. So remote things will be increased, right? You can do it by remotely also. You don't go for the routers places to configure it. Lay the foundation for the intent, right? So here, centralized configuration, management, control monitoring, service delivery, and cloud automation. That all can be monitored with a SDN. To make networks more adaptable and flexible, SDN in IoT is an architecture that easily abstract many different layers of SDN. SDN aims to improve. So SDN is the same with the IoT. If you go for the IoT and we apply the SDN into it, so what we have a centralized unit of networking where we can apply SDN, and we can have scalable kind of networking. How much I want to spread it, how much data packets I do have. If I have a less data packets, we don't need to take the much, kind of a high operable SDN system. We can scale it in our way, right? So in a control layer, when we have anything like Wi-Fi, internet, Zigbee, these all can be controlled with this SDN, and the data is sent to the different application layers like data path control, user authentication, mobility management, IoT apps, right? Different type of software defined networking. So there are some type of SDN. There are some classification of SDN, which is OpenSDN. OpenSDN uses open protocols to control the virtual and physical devices responsible for routing the data packets. Right? It's an open SDN. Right? So it can configured openly. API SDN uses programming interface called southbound APIs to control data flows to and from each device. Right? Third is overlay model SDN. Overlay model SDN creates a virtual network above existing hardwares, providing tunnels containing channel to the data centers, and this model then allocate bandwidth in each channels and assign devices to each channel, right? And next is hybrid model SDN. Hybrid model SDN combines SDN with the traditional networking, the networking we follows, and allowing the optimal protocol to be assigned to each type of traffic. Hybrid SDN is often used as a phrasing approach to SDN. So hybrid model sometimes used with the protocol we generally used with the traditional networking. The same protocol is hybrid with the software networking, right? So these four types of networking, SDN networking, we can do. Why software defined networking is important in IoT? Because of increased controlled with incredible speed and flexibility. Obviously, SDN make the speed greater. So that's why we need to have this kind of system in our IoT, right? Increased control with incredible speed and flexibility. Second is customizable network infrastructure. Network infrastructure can be customized with the help of SDN. Of course, it is a kind of a software. So that's why we can change the network infrastructures whenever we want, right? So we can customize it according to ourselves, what kind of infrastructure we want in networking, right? And robust security. Security can be also done with multiple layers, right? If you go for it, so we can apply multiple layer securities with it to secure our data, right? And the critical difference and what is the difference between software defined network and traditional networking? The same thing. The critical difference between SDN and traditional network is infrastructure. SDN is software based while traditional networking is hardware based. Because the control panel is software based, SDN is much more flexible than traditional networking. It allows administrator to control the network, changes configuration setting, provision resources, and increase network capacity from a centralized user interface without adding more hardware. Additionally, there are security distinction between SDN and traditional networking. Software-defined networking offers superior security in more aspect because it is increased visibility and capacity to define safe paths. But since software-defined networks rely on centralized controller, protecting the controllers is essential to upholding the security of network. Right. So it can automatically, the intelligence is all upon this software networking. So it can easily track which path or which location is not authenticated basically. Right. The authentication can be also done with the help of software. Right. So the hacking system or hacking process will be less applied will with this study with this software networking, because there are way where we can actually sense that which kind of path we need to follow and which is not to be followed, right? So this is basically SDN, and this is in networking of with the help of softwares, right? Like we do with the nowadays we are doing it with the traditional hardwares. So it will be replaced by the SDN so that it can be controlled in a centralized way, right? With SDN. Okay. So I think SDN and the previous topics are done with you. And if you have any doubts, you can ask me. Hello. If you have any doubts in previous topics that we have covered in the previous sessions and the recent sessions, if you have any doubts, any queries, you can ask me, or the session is done now from my side.
All the participants are instructed to on the camera to take the group photo. Ritesh sir, can you please stop sharing?
Yeah, of course. Okay, thanks a lot to all of you guys. So hope the session enhance your knowledges, right? And if you have any doubts today, you can apply and you can think about it and you can work on it. And after that, tomorrow when we'll sit, then we can discuss about any doubts and anything else from the today's session, right? So that will be done tomorrow. Okay.
Now it's time for vote of thanks for session day 1. As all good things come to an end in life, so is the first day of this FDP. On behalf of Godavari Foundations, Godavari College of Engineering, Jalgaon, St. Francis Institute of Technology, Mumbai, and MH Sabu Siddiqui College of Engineering, Mumbai, I thank our today's resource person, Mr. Ritesh Kumar. We are really enlightened with your knowledge and presence, sir. A special thanks to the organizing committee for their support and coordinations. Our heartfelt thanks to our active participants. With these warm words and a kind message, we move to the end of the first day of IEEE Bombay section sponsored 1 week faculty development program online capacity building workshop on blooming research areas under IoT, a 360-degree view. Thank you. Thank you once again.
Thank you, ma'am.